Consider the following function and its graph on the interval 0 to 6. So here, let's look here. So here's a function, and there's its graph. It goes from 0 out to 6. You can see those little marks down there. This is 6. This is 0. So we're looking at the graph of a function that goes from 0 to 6. Okay, and what we're going to do on part A here. So I want to approximate the area under the curve over the interval 0 to 6 using only two boxes, two subintervals, and right-hand endpoints. See how this rectangle hits this rectangle right here? His upper right-hand corner hits the curve, and the second rectangle, his upper right-hand corner hits the curve. So both those rectangles are right-hand endpoint rectangles. Okay, so I want to figure out the total area. Well, what's the area of a rectangle? So the area of a rectangle, I'm sure you know, is one side times length times width. So this goes from 0 to 3, so its width is 3. This one goes to 6, so his width is also 3. So that's the width. The width is 3. What's the length or the height, whatever you want to call it? How do you know how high up this rectangle goes? What's this height up here? You can try to guess on the diagram, but it's hard to see. And a better way is just to use the function because remember, this is your y. Function values are y values. So y is 3 plus 12x minus x squared. So then when you plug in, so how do you know how high it goes? Well, it hits right here on 3. So you plug in x equals 3 to that equation, and you'll get this height. So this y value at x equals 3 is y equals 3 plus 12 times 3 minus 2 squared. So I'm plugging in 3 to that function, you see? And so I get y equals 3 plus 36 minus 9. So I think that's 30. Through 9. Yeah, it's 30. So y is 30. So that means the height here is 30. The height must be 30. So the area of that first rectangle is 3 times 30, which equals 90. Because it's 3 wide and 30 tall. How do I know it's 30 tall? When you plug in x equals 3, it hits the curve. So that point, that's probably the best way to see it. Let me erase some of this now that you've seen this and just say, hey, look, we know this. We know this is the point over 3 of 30 because I plugged in 3 and y came out at x equals 3, it came out 30. So that means this is 30 tall and 3 wide. I'll put the wide at the bottom. 3 wide. Okay, now for the next one, he hits up here at 6. So this is the point over 6 up. I don't know. Let's find out what y equals at x equals 6. So let's plug in again to the formula. So and y equals 3 plus 72 minus 36. I think that's 39. So this is 39. So that means this thing is right here. This is 30 over here. I can do it over there. Probably better. This thing is 39 tall and again 3 wide because it went from 3 to 6. So this rectangle is 3 times 39. So the two rectangles then, let's put it together. We've got 3 by 30 plus 3 by 39. So that's 90 plus, what's that? 90, 27, 117, I think. 90 and 27, 17, yeah. And so that's 207. Oh yeah, that's the area. So the area of those two rectangles is 207. Let's do the next two. So down here, same thing, you got a couple of rectangles. This one hits here. This is left hand. So the left side of this rectangle hits. So that's at x equals 0. So I want to know this is over 0 up what? So again, it's the same function. Y equals 3 plus 12x minus x squared. That is our function. And we're going to plug in at x equals 0. Y will be 3. It's 12 times 0 minus 0 squared. Y is just going to be 3. So this is the point over 0 up 3. And how wide? Well, it goes over to 3. So the width is 3 and the height is 3. So that's a 3 by 3. That's 9. Okay, now let's do the next part. The next part hits right here. This is the point over 3 up, I don't know, let me find it, at x equals 3. Well, actually, I already found that earlier, huh? I can just look back up. At x equals 3, it's right up here. At x equals 3, y is 30. I already know that point. That's over 3 up 30. Found that earlier. So that means this is 30 tall and 3 wide. So our two rectangles then are 3 by 3. This one's only 3 tall and 3 wide. Plus the other one is 3 by 30. This one's 3 by 30. This one's 3 by 3. So that's what? 9 plus 90. That's 99. 99. And there we go. We can clearly tell that these two rectangles are an overestimate. Here's the curve. The area under the curve, these two rectangles go over that. So this is an overestimate, way over. And these rectangles leave a lot of area out. This is a serious underestimate. So the real area underneath the curve is somewhere between 99 and 207. And how would you find the real area? You got to take more boxes. This is only 2 boxes. And we saw in earlier examples, the more boxes you take, the tighter the fit until you have an infinite number of boxes and a perfect fit. That's the idea. There we go.